This is example 2 in section 4.3. So we want to find the derivative for the following function x cubed minus x squared. So I've written the definition of the derivative, which entails a limit of f of x plus h minus f of x over h. So the first thing we're going to do is find f of x plus h. So when we want to determine f of x plus h, we want to replace x with x plus h. So we're going to get x plus h cubed minus x plus h squared. Now to evaluate this, we need to do some expanding of binomials. So a cubed means you're going to expand the binomial 3 times, and then you're going to expand the binomial twice. So there's a bit of algebra involved here. So normally when you have 3 binomials, you work with 2 at a time. So I'm going to keep the first binomial and I'm going to expand the second 2. So I'm going to get x squared plus 2xh plus h squared. Again, I'm going to expand these 2 binomials, x squared plus 2xh plus h squared. Now I'm going to FOIL out the binomial with this trinomial. You will get x cubed plus 3x squared h plus 3xh squared plus h cubed minus x squared plus 2xh plus h squared. So with all these terms, nothing cancels. So we're going to put that into the definition of the derivative. So I'm going to get the limit as h approaches 0, and I'm going to substitute all those terms in my numerator. So we said it was x cubed, 3x squared h, 3xh squared plus h cubed. Put brackets around that. We also had an x squared plus 2xh plus h squared. So that's the term f of x plus h. We still have to subtract that from the original function. And the original function was x cubed minus x squared. So there's a lot of terms going on here. And it's all divided by h. So our goal is for terms in the numerator to cancel. So when we look at this, we see this x cubed cancels with this x cubed. This subtraction makes this x squared with a subtraction positive. So that's really positive x squared. Now this subtraction will go through. So I will have a negative x squared canceling with this positive x squared. So then I'm left with 3x squared h, 3xh squared, h cubed, minus 2xh because the negative distributes through, minus h squared, all over h. So then you'll notice that the numerator entails h in all the terms, so I can take a GCF out. So if I take a h out, I have 3x squared, 3xh, a h squared minus 2x and a minus h all over h. So I'm going to keep going with my derivative. So I get the limit as h goes to 0, the h's cancel, which is the goal, and I'm left with 3x squared, 3xh, h squared minus 2x minus h. Now, f prime of x equals, when I apply the limit and substitute h to be 0 in for h, there's no h in that term, so I know I'm left with 3x squared. If h goes to 0 here and I multiply, I know that's gone. h goes to 0, I know that's gone. I'm left with a minus 2x, because there's no h term, and this h goes to 0. So my derivative is 3x squared minus 2x, which stands for the equation of the tangent line for the graph. And if I gave you a number for x, you could find the slope of that tangent for any value on the graph.